This is lesson 67, sigma notation, pages 154, 155. Sigma notation is a short way of writing series. It's you can do it for arithmetic, you can do it for geometric, you can do it just for series that maybe we haven't even seen, and I'll give you some examples of what you might have on that. And all we're doing today is simply learning what the notation is. You're not doing any arithmetic in terms of adding like a series. We'll use that in future lessons. So the symbol that you're given is the sigma. You've probably seen it in sororities and fraternities. And it's the capital letter sigma. And you're going to see below that, and they use different letters. I was trying to look and see in your classwork whether they stick with N's. Sometimes people stick with N's, but you don't have to. Now, ours will always start with 1, and then you will have an ending number at the top. You'll understand what I'm talking about here in just a second. Let's put a 6 there. And then you'll be given a formula. A generic equation is probably the easiest way I want to say it. For example, if you had, say, 4n. And sometimes you see those in parentheses. If it's got adding and subtracting, you usually will. Now, we can go ahead and put equals. Now, this symbol means it's the summation symbol. And it means the sum of. It means we're going to actually find the sum of a set of numbers. Now, today we're just writing what it means, because that's the hardest part that I have found students struggle with is what does this, how do you interpret this? So, the first thing I know is if I'm going from 1 to 6, that means how many terms I'm going to have. So I'm going to put blank plus blank plus blank. So I got 3, 4, 5, 6. I ran out of room there a little bit, but I think you can see it. Okay. So just like we've done before when we were given an explicit formula, then we can take the number 1 and put it in for n. So I would have 4 times 1. So my first term is 4. And we're going to go all the way to 6. So 4 times 2 is 8. 4 times 3 is 12. 4 times 4 is 16. 4 times 5 is 20. And 4 times 6 is 24. It's a pretty simple one. Now, when you look at that, in this case, this is arithmetic, because notice that you're adding 4 every time. It may be arithmetic, it may be geometric, and it may be neither one of those. We'll see some of those in just a second. So we'll label that as our first one. Okay, let's do the summation of, let's go from k equals 1. Again, you'll see in upper classes, sometimes you'll see it start at different numbers, but we're going to start at 1 every time. And let's go to 5. And let's do the sequence, let's do 3 to the n. Okay, let's see what's going to happen with that. So my first term, and again, you don't have to show this work up here. This was just the work that I was doing mentally to get my terms. It helps you with your notes if you want to know where it's coming from. So on this one, I'm going to do 1, 2, 3, 4, 5. Now, we'll be finding the sum of those later. A lot of that is you're going to have to decide, is it geometric, arithmetic? Can we find the sum of it without having to write them out and add them up? So my first term would be 3 to the 1, which is 3. 3 to the second. Oop, I put it in the wrong place, didn't I? 3 to the 2, which is 9. 3 to the 3, which is 27. 3 to the 4th, which is 81. You may have to use your calculator on some of these. And then 3 to the 5th is 243. So, and in that case, you can see that it's a geometric one because you're simply adding, you're taking your first term, which is 3, and you're multiplying by the common difference, which is, oh, I think I said that wrong a while ago. This is your common difference. D was 4. Here, case R is 3. I may have said that was R up there. So D was 4. That was arithmetic. This one's a geometric. Let's do another one. I mean, that's all you're doing in this lesson. You're not adding them up. You're not even having to decide what they are. I'm just supplementing that with the information that we already know. Let's do M is equal to 1 to 4. And let's do Oh, let's see what I've got. Let's do m times m plus 3. Okay, we're going to do 4 of them. 1, 2, 3, 4. So my first term would be, I'm going to put 1 in for m here and here. So I'm going to have 1 times, if it's okay with you, I'm going to go ahead and do 1 times 4. And then the second one would be 2 times 5, because I'm putting 2 times 2 plus 3. And then the third one is 3 times 6. See, 3, and then put a 3 right there. And then 4 is going to be 4 times 4 plus 3, which is 7. Now, it's kind of interesting. If you look at your 1, 2, 3, 4 here, you'll notice that's arithmetic. You're just adding 1 every time. And on this one, it's an arithmetic, and you're adding 1 every time. 4, 5, 6, 7. But when you put them together, let's see, you've got 18 and you've got 21. Now, there's probably a pattern as you're looking at it. See, from here to here is 4, and then from here to here is 8, and then 18 to 21 is going, oh, how about 27? 18 to 27 is 9. And so there are patterns. I cannot multiply. Let's try that one more time. How about 28? Okay, so we went from 4 to here was 6. Now that sounds more, you can kind of see the pattern. 4 to 6, you add 4 to 10, you add 6. 10 to 18, you add 8. And then 18 to 28, you add 10. So you see a pattern, but it's not adding the same thing every time, and it's not multiplying by the same thing every time. So this is a series, but it's not geometric, it's not arithmetic. So you have to have several different types of sequences and series. They don't always have to be geometric or arithmetic. Let's do a fourth one. Let's do one that involves some squareds. Let's do, I don't know what other letters they use. They use, that's what they do, ends. We did that. That's probably the most common ones. Let's do, we'll just go back to n, and we'll do from 1 to, what is the number we haven't done? How about 3? We'll do a pretty easy one. Oop, let me slide that where you can see it. Okay, let's do 15 minus n squared. Okay, just, you know, kind of an odd looking equation, but we can set it up. So we're only going to do 3 of them. Okay, so we're going to put 1 in, we're going to put 2 in, and then we're going to put 3 in. So I will set the arithmetic involved. So I've got 15 minus 1 squared, and then 15 minus 2 squared, and 15 minus 3 squared. So that's 15 minus 1, which is 14. That's 15 minus 4, which is 11. And then this one is 15 minus 9, which is 6. So this one, I went from 14 to 11, and I subtracted 3. From 11 to 6, I subtracted 5. Not arithmetic, not geometric, but it is a sequence. It is a series of numbers that has a pattern, and this is the pattern that you're using. That's what you're doing in your classwork. You're only going to be taking the sigma notation, and you're going to be writing the terms.